This lesson, 8.6, is dividing radicals. And so whenever you are dividing radicals, if you look at this one right here, the square root of 18 divided by the square root of 2, you could always put the whole thing underneath one radical, just like we do in multiplying. Okay, and so in this case, you can put it under one radical. 18 divided by 2 is 9, and the square root of 9 is 3. Okay, if you look at this one over here, we put it under one radical and we divide it and we get the square root of 8. Now, the square root of 8 is not a perfect square, so you have to factor that out. Okay, um, and so that's what we're going to be working on right now. So the first thing that you want to do, step one, is simplify the fraction inside of the radical if you can. So in this case, we can. 32 divided by 8 is 4. You keep it under the radical until you start factoring out, okay? So then we get the square root of 4, and the square root of 4 is 2, okay? All right, we're going to do the right side. Now look at example 2. This one's a little bit different. This one is 64 divided by 49. In this case, I would not divide those because 64 is a perfect square and 49 is a perfect square. So the square root of 64 is 8. And because I'm factoring out the 8, I don't put it under a radical anymore. And the square root of 49 is 7. Okay. Now, if you did divide 64 divided by 9, you would end up with a decimal. So you can take the square root of 64 divided by 49, and you end up with this long decimal. So I don't want these long decimals. I want the fraction or the factored out radical, right? So you're not getting decimals in this assignment. Okay, the next one, example 4, we have the square root of 52 divided by 2. 52 divided by 2 is 26. Okay, and when I try to factor out 26, I get 2 and 13. So that means that I cannot, there's nothing to group these two numbers with, so this is your final answer right here. Okay, the last one on this side is the square root of 8x cubed divided by 50x. Remember, I want to try to reduce what is inside the radical first. So I'm going to rewrite this whole thing. We have 8x cubed over 50x. So I'm going to find the greatest common factor between 8 and 50, and that is 2. Okay. Yep, 2. And then the greatest common factor between x cubed and x is x. So I'm going to divide or reduce the fraction inside of the radical by 2x. And so I'm not factoring out of the radical, I'm just reducing the fraction inside. So we keep the radical symbol. So 8 divided by 2 is 4. X cubed divided by x is x squared. 50 divided by 2 is 25, and then x divided by x is 1, or it just cancels out. Okay. And so now let's look at this. Are these perfect squares? Yes, they are. The square root of 4 is 2, so now I'm factoring out, so I'm going to end up getting rid of the radical. The square root of 4 is 2, and the square root of x squared is x, and the square root of 25 is 5. And we're done. I would say that the biggest obstacle would be remembering when to keep the radical and when to get rid of the radical. Until you start factoring, you want to keep the radical. Here we just reduced the fraction. Here we actually found the square root of these. So I guess I could say it a different way. Whenever you're square rooting something, that's when you start getting rid of the radical. Okay. All right, so what I want you to do is I want you to do practice 1 through, oh, we're missing number 3. Oh well. I want you to do the right side of this paper, and then when we come back, you'll see the answers on the screen. So go ahead and pause your video. Okay, here are the answers to practice 1, 2, and 4. These two were very similar to our example problems. This one was slightly different. You may have stopped at the square root of 24 because we did over here, but the thing is 26 is not factorable. 24 is. So I had to create my factor tree, and I have 3 2s and a 3, so I put that under the radical because remember, our prime numbers here are replacing the 24. And then I group my 2's together, and I'm left with a 2 and 3 inside. So I end up with 2 times the square root of 6. Okay. And then here is the answer to practice 5. Okay, very similar to example 5. All right, let's go ahead and go to the back. This is slightly different, and I'm going to try to explain this the best I can. In this, remember, I don't want decimals. I want radicals as your answers. In this one, I am going to take this out of the radical. Not out of the radical, I'm sorry. I'm going to separate each term into its own radical. What I mean is I'm going to write the square root of 15 over the square root of 2. The reason I'm doing this is because if I were to divide 15 by 2, I'm going to get a decimal. And remember, I don't want decimals. And neither one of these are perfect squares, nor can I reduce the fraction any further. Okay, so I cannot leave it like this. And the reason I can't leave it like this is because we cannot have a radical in the denominator. That's against all radical rules. And I don't know if you remember from the very beginning of the school year, we were talking about the real number system. And the square root of 2 is considered an irrational number. And we cannot have an irrational number in the denominator, so we have to make it rational. And that's where we get this term right here, rationalize the denominator. All that means is we need to turn it into a rational number. And every time we turn it into a rational number, we do the exact same thing. If you look up at this one, we took them out of one radical and separated them, just like we did example 6. Okay. Then we took this right here and we multiplied both the top and the bottom by the denominator, the square root of 3. So we multiplied, we took the square root of 3 here and we multiplied it here. So let me show you what that's going to look like here. We're going to multiply the square root of 2. Here, we're taking this and we're going to multiply the top and the bottom here. So what we get is, remember with fractions, you just multiply straight across. So here we get the square root of 15 times the square root of 2. And here we get the square root of 2 times the square root of 2, which is what they did up here. Okay. Now we are going to factor out if we can. So 15 factors out to a 3 and a 5, but then you wouldn't have anything to pair it up with. So for example, 15, 3 and 5, okay? So if I were to rewrite this, I would get 2 times 3 times 5. Down here, I have the square root of 2 times 2. And I can't group anything here, but I can group my 2's out here. So I'm going to take those out. And so what we have is the square root of 30, which is 2 times 3 times 5, over 2, because we pulled the 2 out of the radical. And that's our final answer because we can't factor the 30. We can't reduce anything because this isn't under a radical, so you can't reduce those. And so this right here would be our final answer. The only way that you could reduce this right here is if the 30 was not under a radical, so they both wouldn't be under a radical, or they were both under a radical. Okay. All right, let's do example 7. So this one is slightly different. 18 can be divided by 6. 18 divided by 6 is 3. And we can't factor out 3, so on this one, we're done. So that was pretty simple. Okay. Okay, so here we can't reduce these. We can factor the 8, but we're not going to do that for this one, okay? So we're going to have the square root of 7 over the square root of 8n. And remember, we cannot have a radical. This would be considered an irrational number, and we need a rational number on the bottom. So basically, all that means is we have to get rid of the radical. So we're going to take the square root of 8, and we're going to multiply the top of the fraction by the square root of 8n, and the bottom of the fraction by the square root of 8n. Okay, so let's go ahead and do that. You have 7 times 8 times n. And then you have the square root of 8 times 8 times n times n. Okay. So let's go ahead and multiply this out. Well, hold on. We can factor out an 8, a group of 8s and a group of n's, so those will come out. Okay. So now we have 56, square root of 56n over 8n. Now, can we factor 56? Yes, let's see if we have any pairs. So I'm going to come over here to the side. I'm going to factor out 56, 7 and 8, 2 and 4, 2 and 2. Okay. So I'm going to we got to continue this right here. So my 8n can stay the same, but I have to factor out this 56 because it's not in its most simplified form. So I have 3 2s and a 7. So I have the square root of 2 times 2 times 2 times 7 times n. We cannot forget the n over here. All over 8n. Okay. Now let's see if we have any pairs we can factor out. It looks like we can only factor out a 2. Okay, so let's do that. So now we have 2 on the outside, and we're left with 2 times 7 times n on the inside, which is the square root of 14n over 8. 14n, we can keep the radical in the numerator. We just can't have a radical in the denominator. There's one more thing that we could do, though, and that is we can reduce the 2 whole numbers on the outside. We cannot reduce what's in the radicand. The only time we can reduce is if they were both under the radicand, but they're not. So we can reduce 2 and 8. 2 divided by 2 is 1, and 8 divided by 2 is 4. So our final answer here is the square root of 14n over 4. Again, we can't reduce these because they're not both under a radical. And I'm going to make this look just a little bit better here. So there were a lot of steps here to remember. That's your final answer. Okay. All right, let's go and do example 9. On this one, I'm going to do something a little different than I did on example 8. I'm going to go ahead and factor out, or first I'm going to reduce the fraction. First, I'm going to reduce. You always want to try to reduce first. And then I'll factor out if I can. So both of these here can be divided by 4. We're going to divide them both by 4. And then we can also divide them by we could get rid of 3x's. So x cubed. Okay, so let's go ahead and reduce those. So 72 divided by 4 is 18. So we have the square root of 18x, because x to the fourth divided by x cubed is x, over, don't forget our 3 here. And then 20 divided by 4 is 5. And then x cubed divided by x cubed is 1, or we just cancel that out. All right. We cannot reduce this any further. But 18 can be factored out. Okay. So I am going to factor out 18. So up here, we have 2 and 9 and 3 and 3. Okay. So I'm going to put these here underneath my radical. So this equals the square root of 2 times 3 times 3 times x. We can't forget the x in there. All over the 3 square root of 5. Okay. Now I'm going to pull out my pairs from the top, and I can pull out a pair of 3s. Okay. And I'm going to get rid of this really quick because it's in my way. So when I rewrite this, 3 goes on the outside, and I'm left with 2x on the inside. And then on the bottom, I have 3 square root of 5. Now I'm checking to see if I can reduce any further, and I can. My 3's cancel out here. Okay. So I'm going to get rid of those 3's. And now I have the square root of 2x over the square root of 5. And we have another step. We cannot have a radical in the denominator, so we have to rationalize it. That means that we're going to multiply the top and the bottom by the square root of 5. So when we do that, we get the square root of 2 times 5 times x over the square root of 5 times 5. Now in the top, there's nothing to factor out. So that's just going to be the square root of 10x. But on the bottom, we can factor out those 5's, and those go out of the radical. So we've gotten rid of it, meaning we've rationalized the denominator, and we're left with the square root of 10x over 5. We cannot reduce this because they're not both under the radical. So this would be our final answer. Okay. So that was a lot to take in. What I'm going to do is I'm going to go ahead and do the practice ones on the right on the screen. However, if you want to try them on your own and pause the video, please do that. Trying to work them out on your own tends to help you learn, okay? But I know that this is, we're getting a little bit complex on this side, so you may need the extra guidance. So, all right, we're going to go back up to practice 6. So I'm going to rewrite this as the square root of 5 over the square root of x. We have a square root on the bottom, and we cannot have that. So I'm going to rationalize it by multiplying the top and the bottom by the square root of x. Okay. And when I do that, I get the square root of 5 times x and the square root of x times x. In the top, there is nothing to pair together. So we will rewrite this as just the square root of 5x because we can't factor anything out. But on the bottom, we can remove the pair of x's. And we have rationalized the denominator. Again, you cannot reduce these x's because they're not both underneath the radical. So this is our final answer. Okay. All right, let's look at the bottom. The first thing I want to check is, can we reduce this? Okay, and the answer is yes, we can actually take out an x here. All right, so let's divide both of these by x. and we end up with the square root of 16x over the square root of 9. Now, you may notice something about these two numbers. 16 is a perfect square and 9 is a perfect square. And so we can go ahead and square root those. So what that looks like is 4 times 4 times x and the square root of 3 times 3. And so you can eliminate this step if you get it, but we're taking out a group of 4s and a group of 3s. So we end up with 4 square root of x over 3. And we can't reduce that any further, so this is our final answer. Now, some of you may have said, okay, well, why couldn't we have square rooted this at the beginning? And you could square root this at the beginning. It would look like this. So instead of dividing by x first, you would have had 4x, the square root of 16 is 4, the square root of x squared is x, over the square root of 9 is 3, but you can't square root x, so you would have had an x here. And so doing that, then you would have had to rationalize the denominator, okay? And so then we would have multiplied both the top and the bottom by the square root of x. And let's see, make sure. And so you would have ended up with 4x square root of x over 3 square root of x times x, because you have to multiply those together. And then you could group and pull those out, and you would end up with 4x square root of x over 3x. Did I miss that? Oh, yes. Okay. Then, because the x's are, neither one of them are in a radical, you could have reduced that by getting rid of the x's. And so then your final answer would have been 4 square root of x over 3, which is what we got here, but with minimal steps. So you can see it depends on which method you use. Either one, you're going to end up with the same answer, but one step may be longer than the other. And until you actually try it, or you get used to solving these problems and seeing ahead of time what's going to happen, it really doesn't matter what method you use. Okay. All right. So let's look at this one. Here, we are going to go ahead and reduce these first. Again, 16 is a perfect square. You could factor that out, but I like to reduce my fractions first. And so the greatest common factor of 20 and 16 is 4. And then we can take out an x from each one. Okay. So when we rewrite this, we have the square root of 5 over the square root of 4x squared. 16 divided by 4 is 4. X cubed divided by x is x squared. Now this one's easy because 4x squared is a perfect square, so we're not going to have to rationalize this denominator. So this is just going to be the square root of 5 over the square root of 4 is 2, and the square root of x squared is x. So that didn't require hardly any work. Now, if you would have square rooted this, then you would have had to rationalize to the denominator. But again, you'll end up with the same answer. You just might have to do quite a bit more work. Okay, let's do this last one. I'm going to go ahead and reduce this by 2y to the 5th. 2y to the 5th. 2y to the 5th. So let's see what this looks like. So this one may be lengthy like this one. Let's see. We have 2. Can't forget the 2 on the outside here. 50 divided by 2 is 25. X to the 6th divided by y to the 5th. I'm sorry, y to the 6th divided by y to the 5th is just y. Okay. 28 divided by 2 is 14. And then y to the 5th divided by y to the 5th is just 1. Okay. All right. Now, if you want, you could go ahead and factor out 25. It's a perfect square. I don't see why not. So if you factor out 25, you end up with 2. The square root of 25 is 5, so we're just going to pull a 5 out, but I'm going to write this out right here. 5 times y. And then that way you can see what's happening. So I'm going to pull out this group of 5 and multiply it by 2. So I end up with 10 square root of y over the square root of 14. And I'm going to come down here and rewrite this because I'm running out of space up there. Okay. 14 is factored out as 2 times 7, so you really can't pair any together. And so now we have to rationalize this denominator because we have to get rid of the radicals. So I'm going to multiply the top and the bottom by the square root of 14. And when I do that, I get, don't forget your 10, 10 square root of 14y over the square root of 14 times 14. And at this point, you can factor out the 14. Okay. And now we have 10 square root of 14y over 14. Now we're not finished because we can reduce the 10 and the 14. Again, we can't reduce the radical part because these two are not under a radical. So 10 divided by 2 is 5. 14 divided by 2 is 7. So our final answer is 5 square root of 14y over 7. Okay. And that concludes lesson 8.6, dividing radical expressions.